coming back. Thanks for the introduction. Yeah, like it's just a little bit about me. Like I am I would call like an academic in recovery. Like I left academia, I graduated, I got my PhD, I left academia, and then kind of like I always been in the open source world. I introduced like through my advisor in the past, and then I kind of like dive into the industry, and then now I'm kind of work with Dask, and then as I mentioned, it's like an open source project. It's like a well-known open source project. I'm going to go a little bit into detail with that. And then currently, yes, I work for Coiled, which is a company, is a Dask company where we kind of like makes deployments and then like get Dask clusters very easy for you. So then kind of going back to what Naty was mentioned is that, okay, now I have more data and I want to scale, but I don't want to go through the trouble of deployments and all the stuff. So today we're going to be talking a little bit about Dask and a little bit about Coiled and how that makes kind of things easier. And I'm going to try to do like 1 or 2 demos. And then if folks in the future are more interested in going into depth and then having like more a tutorial, we give some tutorials. You can kind of register for those, and then we can give like one more tailor for the meetup. So yeah, so with that, let's just get started and let's dive into what this. So Dask, as I mentioned, is like an open source library and basically provides like multi-core and distributed parallel execution on larger than memory data sets. And that makes parallelizing Python very easy. It says everything is very Pythonic, and you can just parallelize your existing Python code, or if you have things like pandas or scikit-learn or NumPy or things like that, then there are like APIs that are high-level APIs that are like kind of really close to what those things that you're familiarized with look like. And once you kind of like want to scale up and then kind of get into the big machines and then get it working in clusters, then that's when coils come into play. And then we're going to see how to do that. So as I mentioned, Dask is like it's like an open source library, have been around for around 10 years, more or less, maybe a little bit less than 10 years, but it's well used across like multiple areas. Scientific computing in general is an area that a lot of people use it, like geosciences, image processing, data science in general. There's some applications in ML, and there are like some satellite projects that are like Dask image, Dask ML, Dask other stuff that kind of integrates with Dask. But then like the core one, it's in this repo. It's like if you look for Dask in GitHub, then you'll end up there. And yeah, it's like there's a big community. Currently, something that it's interesting in is like most of the contributors, the main contributors to Dask are usually backed by some company. So they are either from NVIDIA, Anaconda, Saturn Cloud, Coiled, and that kind of like makes the project more, if you would say, faster to a certain extent. So before like we just start diving into what Dask does and so on and so forth, let's just like see an example. So I'm going to show you now like a quick example where basically I would guess, because most of you probably know, I'm going to make this bigger. Most of you know what matplotlib is, right? And basically what happened is matplotlib is being used across the scientific community for a long time. And the matplotlib folks were trying to figure out, okay, how many people are actually using matplotlib? And Archive has a way of, basically has like a keyword, like in bytes, that is matplotlib, that you can actually, if you can scrape that, you can see how many papers on Archive have been using matplotlib. The thing is, matplotlib has around 3 terabytes of data on PDFs. So trying to kind of go all over all of those will be hard. So there was at a point that this plot was done, but then they lost the reference and that they couldn't kind of like get that going. So there was a chat that one of the Coiled CEO, like Matt Rocklin, which is creator of Dask, and then Tom Caswell, one of the main maintainers of matplotlib, says that let's see if we can just get this going with like some Dask code or some Python code and then kind of parallelize it with Dask. So that was kind of like the problem. And if you kind of look into the S3 archive, like for the PDFs, you will find a bunch of these tar files that have like some weird naming. And inside of those tar files, like you would see like, for example, one of them, then like you can see they will have like multiple PDFs, and then inside those PDFs, like there will be like an insane amount of PDFs. So like, I think like the amount of directory is like, yeah, it's around 6,000. So then and inside there's that we have more. So the way that you will process some of this file is one file will be like with some sort of junky Python code. We all have some junky Python code around that we use to process something, maybe to process some data. And I don't want to get in too much detail of what the function does, but basically what it will to return if like a true or false, whether they have this like matplotlib kind of keyword in the PDFs. So, so we just run that, and then let's just try to go over like a couple directories quickly, or one of them quickly, and then this will now be in a parallel fashion. So that will take probably a couple of seconds. Now, the thing is, we can get a record of each file and whether or not they have, like, for example, this ones are the early ones. It's like false, false, false. Like matplotlib wasn't there, probably it was early on. But each of these ones, like if it takes like around like running 20 or so, it will take up around a minute or like a couple seconds. But like if we have 5,000 files, that will take us like around 100 hours to make this in like just a straight Python. So, but we can actually make this happen in a kind of easy way. There are like two components. One is like making the process happen closer to the data. So the data is in the cloud, it's in S3, and like the networking to get it to kind of my laptop, it's like takes a while. So then now we can work closer to the data by getting an instance or clusters closer to the data. But then also we can use hundreds of workers and hundreds of machines to kind of make this run in parallel. So for now, we're going to create it as a cluster, and I'm going to use Coil. I'm going to get into some details later on how to do it, but for now, just to showcase, it's like this. Oops, what happened here? Oh, I forgot a comma here. So basically, I'm just getting a cluster. I'm asking for 100 workers. This is an instant type. And then in this case, I'm just getting, I should have put east here. Well, we're going to get some workers. We're going to see what do we get. But the thing is, yeah, I got that error. Sorry about that. This is happening because I was playing with this before and I made a typo. So let's try to get this in here. Let's see if we can make that. But yeah, it's like what's happening here is what you're seeing is I'm requesting machines in the cloud. I'm trying to sync up with the packages that I have on my local laptop, and Coil is kind of taking care of that. And then I'm running like validating the environment, and then I'm seeing that, okay, I requested this instance type, so I'm getting those. And within a couple of minutes, it's usually around a minute and a half, I get like 100 machines in the cloud, and then I don't have to worry about any kind of deployment. So, oops, sorry, the scrolling in the big sizes, kind of that. So yeah, so you see in this we got this kind of nice widget that integrates with the notebooks. The notebook is in my laptop. So currently I'm running this on my laptop. I mean, like the notebooks is in my laptop. I created a conda environment, and then now I'm just about to send the computation to the cloud. So just getting that environment ready. And then now like my workers are getting ready. So then I'm getting about 20, 30, 70. And I said, okay, most of your workers have arrived. So in a minute and 15 seconds, I got 100 machines in the cloud. Now I can just run all this in parallel. So the one thing that I need to do is I need to connect my laptop to those machines in the cloud. And the way that we do it is like with a distributed client from Dask. And once we connect it, we just get this wrapper that tells me a little bit of info about the cluster, the workers, the threat. And then we got this nice dashboard that I'm going to put like right next to it. And so you'll see here, like when I start doing things, this dashboard, this is a Dask dashboard. It's not proper that Coil. It's like anyone that runs Dask will see this. And then now the only thing I need to change to be able to run this in parallel is basically just make this a little bigger.
We have a question here. Somebody asked,
yeah.
Is Dask only on AWS or just this example is AWS?
This example is AWS, but Coil will, let's say, you can bring your own cloud, and as soon as it's AWS or GCP, you can connect Coil to your own AWS account or your GCP account. Dask can be deployed like pretty much anywhere. Like if you want to use it through Coil and get clustered via Coil, it's like currently we support AWS and GCP. That's a great question. And then now if I want to run the thing that I ran before, that extract function, I just want to map it to all these clusters. The way I will do it, I'll create these futures and I will do a client map. And literally after that, I will like get this running in the cloud. So now we should see like soon in here, some activity happening. And then what you see here is like each of the workers is like doing some call of this extract function. And then we see that there is like 5,929. That was the amount of directories that we have. And then in about probably 2-3 minutes, this will finish. So we're going to let this go in. And then I'm going to continue. And then we're going to come back and then see what we got and then reproduce that plot. So that's kind of like what we saw. And then like the interesting thing is, the beauty about Dask is I just have some Python code that looks something like this. I have a sequential code and I have to process one file. And then now if I have multiple files, that will be for file name in the list of files. I have some sort of processing happening and I need an output and I will append it. And the way that we go to run this in parallel with Dask is just by tweaking this a tiny bit. So now we still have that kind of for loop, and then we'll have this client submit, or we can replace the for loop for a client map. That's kind of like, depends on the situation, but the changes are really, really small. And suddenly now we're like just running in the cloud. But you might wonder, is that, okay, is this the only thing they can do with Dask? Because this was like an embarrassingly parallel example. And not always like things are embarrassingly parallel. So Dask and Coiled like are general purpose. So multiple things that you can do, as we mentioned, was parallel for loopy code, like something that is simple, that is like an iteration, and I repeat the same process multiple times. But then it can also do more complicated for loops, something that, oh, well, this task depends on something that happens before, and then we just need to kind of do different things. It can get as complicated as we want, and then they're like the APIs, especially the Futures API, provides like ways of kind of controlling the flow and being able to run things more complicated in parallel. The other thing that is very common is things that are like data frame-like. If you work with pandas every day, but then now you have like multiple data, it usually can be chunked up into multiple CSV files, or ideally in multiple Parquet files, which are more optimized. And then we can perform operations with data frames, very similar like with pandas. Now, a Dask data frame will be composed of multiple pandas data frames, and it will have like it will handle the parallelism on the back. Other things that also Dask does, and it has like an API for that, is things that are related to arrays. So if in your workflow you work more with arrays, and arrays suits more your application, then arrays are also the operations can be parallelized with Dask, and there are a lot of built-in things on the API, the Dask array API. And then last but not least, like Dask can also, it's very flexible to integrate a lot of things that are related with Python. We have like XGBoost, and then like Optune and JobLib and Xarray, and then there are like multiple libraries that can integrate with this. So we can see another example where like actually what we do is something more like data frame-like, and then and in the meantime, we can also check what is our example. So we see that it finished here, or it's about to. It's like almost there. It's just gathering the results. There it is. So it took about 3 minutes and 45 seconds to finish something that if I would have run it a for loop would have taken me 100 hours. So now I don't need this cluster anymore. So then I can just close the cluster. And then now I can just go back to my laptop and then keep working on Pandas name. In this case, I'm just going to concatenate some stuff, not doing any of that. This is just post-processing, but for the sake of showing is now in a matter of 5 minutes or so, we just get like that plot that here doesn't look that great, but like with some formatting, we can get that plot. So then now basically this for the Matplotlib folks, it was like very important because they can say, well, Matplotlib is really well used. So then they can go to NSF and they get some grants and then do some things. So it's like something that we have some code working and then now we can just parallelize. Another nice example we can do, and then this, I'm going to show you a little bit more on how you in general like will go about this. And then so you see that we're running things from a laptop. So this is my terminal, this is my laptop. And I have just a conda environment that has a couple of things. You can see what's in there. It has some libraries, but has IPython, and it will have some bokeh and all this stuff that I just need to run this example. But basically what we do is we just launch a Jupyter Lab or a Jupyter Notebook. You can use IPython. You can do this from your script. Your Python script. Doesn't matter where you run your Python code, you will be able to create a cluster. In this case, I'm going to show you like an example that is more like data frame-like, and we're just going to visualize about like a 1 billion points in an interactive way. So in this case, we just import data frames and Dask data frames, and then we have like data shader and HBplot. Are other libraries that are more for plotting at scale and integrate well with Dask. And I'm going to get a different cluster now. I'm going to get just 20 workers. I don't need that many. And we're going to see that like widget going on again, which in this case looks a little bit. There you go. I mean, now we are on US East 2. This is closer to the data. To this data set that we're going to be working, so then I can quickly switch where do I want my instances to pop. And now I'm getting this T3s out of the default in this case, so we just get a couple of these instances. And here, like while we get the cluster, you'll see that like the operations that we're doing here are really, if you work with pandas, they should be fairly friendly. So you're just like reading Parquet from some S3. You're only grabbing some columns. That's kind of one of the beauties about Parquet, that like I don't need to bring in everything in memory or everything at all. Up to this point, I'm only creating a graph. I haven't computed things yet. And then we're going to do some sort of cleanup. And we're going to create some columns. We're going to rename some of those columns. We're just doing some kind of ETL workflow that anyone will do. And then we are going to just basically do a nice plot with this. So we got the workers. So I'm going to, I think, yeah. So now I need get that client. So just need to get the link. So let's just do, now we're going to go to a different one. And now we're going to run that, like that code that we see. Like we're just reading here, we have like around 5 years of New York City data. And then what we're doing is we're also creating like separating the pickup data from the drop-off data, so then I can just get the different points and then plot them in an overlap way. So it's like this nice dashboards that give you some information about what's happening. It's usually very helpful when you want to see what's going on and what type of like tasks are happening and what the memory is going on in here. Yeah, it's like it becomes very handy when you're looking and see what's happening. So one of the things that it's kind of interesting and that we're going to see now happen is this repartition component. When you start like working with distributed data, something that happens, okay, well, now you're reading all this data, you do some manipulation, and then the chunks of the data you're working get smaller as you go. So to be optimized, the workers' work, like you just want to like repartitions for things that are like more handy for the workers. So now we got all that data processing around 1 minute, and then now we're just going to do a pretty plot. And what we're going to see is that it's taking a tiny bit, but it should plot this. And what we're going to see is that as I zoom in and out of this plot, the computations are happening. So let me make it this tiny bit smaller so we can fit the plot in there, but I want to kind of get with this, I can kind of zoom in on an area. For example, if I want, this is like JFK. So you see that, oh, well, we have the pickups and the drop-off area, and then I want to get like a little bit inside, and it's running the computations on the go, and I'm able to visualize like 1 billion points just because I happen to have these machines on the cloud, and then it's available. Then I can zoom out and then see kind of things. So these are like useful things that otherwise, if I would try to do things like this on my laptop, my laptop will blow up. Like basically, this wouldn't be able to run. So now we got those nice, pretty demos. Let's just go back to this. So what we saw is that basically Dask is helping us parallelize the stuff, and that it's just kind of taking care of the algorithms and things on the back. Like we just keep coding and kind of like getting Python code in there. And then Coil, basically what it's doing is just like taking care of the infrastructure. So I can just get a cluster, I can get my machines, I can run stuff, and I don't have to worry much about that. So like, I didn't go through all this process with you. I was just like showing you the stuff, but like the reason why we like Coil or we use Coil, and this is like, it's not only because I have my Coil hat on, it's because it's easy to set up. If anyone would tell me like, oh, I just have my cloud account, and then with 2 simple steps that you will install Coil, and then you will do Coil setup, and that will guide you through a process on how you will link your account. Of course, you need enough permissions of your account to be able to do that, but like in a matter of a day or so, or less, like minutes or hours, that you will be able to get like the amount of the instances up. It's also like fast and informative. I personally in the past have worked with HPC clusters, and then I'm requesting this machine as I have 0 clue of what's happening. I don't know if I get them, where is the queue, I'm just waiting, like there's nothing prompting. And I like that I'm able to see and interact from my notebook and then see like what's going on. So I quickly just get information of that. It's very easy to sync up the package installations. So I don't know if any of you have worked in the past with clusters where you kind of need to guarantee that everything on every worker is installed, and then everything should be compatible with the scheduler and the client. Like, and all the other type of Dask deployments that are out there, like currently you need to kind of handle this yourself. And it's a little bit annoying because I'll spend a lot of time on the deployment, and I spend a lot of time trying to get the right things. And then by the time I get to do my science or my work or my data science stuff, it's just like a couple of days have gone. So it's like in few like sentences, it's like what we do have, it's a rock solid infrastructure that enables like the person that is doing the job is like to get the job done as fast and as quickly as possible, and then like removing the deployment out of the way. So, and this like other things that we didn't go into, but like if folks are interested, is like another good thing about like Coil is like in general, it will be cost efficient. So for example, I currently have those clusters. The last one, I didn't shut it down. By default, it will shut down in 20 minutes, 15, 20 minutes. So if you forgot your cluster up, then it won't just run out of money. Then it usually tries to optimize for the zones that we're having. Like when I'm requesting a cluster, we have some, if you want to use spot instances, like you can enable them, and then kind of Coil will try to handle those. And then so you could save money in that aspect. Then there is observability at all levels. So I currently show you like the Dask dashboard, but like if you were to, Dask has like a Prometheus backend. So if you were to want it to connect that to Grafana, that like you could visualize through Coil more than what you saw on the dashboard. You can get like a bunch of hardware metrics and then see what's happening with the network, like with the occupancy of the cluster, the workers, and then get a little bit more visibility on the bigger picture, as well as the logs and all that. And then last but not least, if like you have a team and then you're managing a team and you want to like onboard people, this is like a fairly easy thing to do. So then you will go through the setup as the team principal, for example, and then just add people to your team, and then people will be just up and running clusters, and they don't have to worry about the rest of the stuff. So kind of to wrap up, basically, we can summarize this as you will start, you have your code, you will parallelize your code with Dask, and then that should be fairly easy. Like if you want to learn more about Dask, like we have tutorials, I'll invite you to go to coil.io/tutorials, and then there are like 2 different tutorials there that I currently run. And there are also multiple resources out there, like in YouTube, and the Dask documentation, and everything is open source. And then once you are ready to scale up, like you want to just add more data, or you just want to run things faster, then Coil can help you do that. And then you can bring your own AWS account, and then you can start scaling up. And then you can use all the features that are extra that teach you about like your workflow, and then through the worker metrics to optimize, and then hopefully also save some money. So that's all what I have for y'all. I'm happy to take any questions. And if, I don't know if I went too fast, I tend to speak too fast, so I apologize if that happens. But yeah.
All right, thank you, Naty, for that. That was very
Yeah,
interesting. So I'll start off with the first question, and this is a popular one these days. Can you say a little bit about machine learning applications and how they could benefit from Dask and Coiled?
Yeah, absolutely. So currently machine learning applications, I would say like the word machine learning is kind of huge, right? And currently we have like everything that is in the ETL aspect, that is like you're like just kind of cleaning data and things like that, and all the data engineer aspect. That's something that Dask does very well, and it's like well oiled. Now, when it comes to training models and when it comes to that aspect, so there is an integration with scikit-learn. There is the things that run at the scikit-learn level, or the Optuna, for example, for hyperparameter optimization. They're like they're like very, very common. So I can kind of like show you some things that we have in as examples. So we recently run some hyperparameter optimization that has like an on an XGBoost model with a custom cross validation, and you can do that. Like I said, just Dask will be very flexible to that. And then like when the data gets like super big, then you can run it with Coil. Like for example, this is one. There are a couple of examples here. Even like with multi-cluster, when you just have multiple data and multiple parameters, you just want to spin up like a bunch of clusters and then do that. So when it comes to XGBoost, like something, let me make this bigger. Just get a cluster, and XGBoost is very well integrated with Dask. Like it has, XGBoost has its like Dask part kind of built into it. So like, this is just like a cross-validation custom that run. But like here, for example, we're just like having a train and a test. This is training on a overlift data, most recent like overlift data from New York City. And it's about, like, I think 700 million rows and just running. And the code should be very similar to what Fox do, just has the Dask component. So for example, here in the model aspect, then you have the train, and this is something, I'm not a super ML person, but I know like the train, and then you have the predict, and then all of this stuff kind of get parallelized like on the back. And yes, in a matter of few, in this case, took like about 7 minutes to go over all those like 700 million and then do 5 faults on cross validation. And then you get some numbers. You get some obtuna ones, like I'll just go over the last. This one was, I believe it is like a classification model. So it have like different things. It's not, what I would say is like, to summarize, it's like, there are integrations, there are things that are still like work in progress, but there are a lot of things that can be done. Like I know there are like some talks in the past or big companies like Capital One and stuff that use Dask to train their models and in production and run things. If folks are specifically interested in learning about Dask and the whole machine learning component, then there is Dask ML, has like integration with JobLib, XGBoost, some PyTorch too. We're currently working on a PyTorch example and trying to get something out there. I'm happy to keep folks on the loop if that's something that they're interested in. But
all right,
yeah.
Thank you. Now I'll open it up to any other questions that people might have.
Yeah, I see there's some in the chat. So it says, regarding benchmarks, I knew this one was coming. How does Dask compare with Spark and PySpark? So I think like when it comes to benchmark, it's a little bit kind of hard sometimes like to compare, and depends on the applications. If you are interested in knowing about Dask benchmarks, so we do have Coiled. So this repo, which is currently called Coiled Benchmarks, runs multiple benchmarks on kind of common workflows and things like that we do. So you can this is open source, it's open for everyone, and then you can kind of click in here. Well, something happened that's not working, but is the button not working? But we're gonna get it there. But like, I'm gonna make sure it's fixed by the time you click. But there are like nice plots and multiple places where you can see the how Dask itself works. I would say that when people ask about whether to use Dask or PySpark, I would say that like the important thing here is like Dask is very Pythonic. So if you have everything in Python, and then your team and data science, or you're used to Python, then you don't have to worry about learning more of like the Spark kind of syntax. Now, if you already have things on Spark and then you want to convert, it's very problem dependent, and sometimes it's more of like where your data is and then what you're doing. There are a couple of benchmarks and comparisons. I usually don't trust them like a lot because sometimes they're like biased towards one or the other, and that's because usually the person that runs them knows more about either Spark or Dask. But that's one of the things that are there. There are like a couple of blogs and stuff like that. It's like I think there's this one, the Matt Rockling wrote. There's called Dask as a Spark, Dask versus Spark. I'm happy to link it in the chat if anyone wants to kind of read about that. But yeah. Then I see. Says, can this be configured to process parallel HTTP requests with very modest payload, no more than 100 KB? And how are the IAM permissions handled? Okay, so for question one, I'm not fully sure I quite follow the question because I am not very familiarized with the application. But my guess would be yes. This is like kind of running a request and processing stuff as you go, and then running multiple ones. I would say the answer is yes. So one of the things that we do in one of the tutorials is that we go through a Stack Overflow multiple pages, and then we kind of scrape data and then do some analysis, and that has some requests in it. The beauty about having the coiled clusters or all these machines is like every of the workers has its own public IP address. So then for a Stack Overflow, if I would try to run that from my laptop, I will hit throttling right away. But from the cluster, it's like these are 10 different machines. So it's not that they're doing 10 different requests from the same machine. How are IAM permissions handled? Yes. So we do have a blog coming up on that, but then like on the coiled docs, I believe, let me see, probably I'm going to get a better shot at Googling this. IAM permissions. Yeah, I would say here and here. So IAM policies. So I'm going to just paste this in the chat because I personally don't know a lot about how these are handled, but I know that my team have put a lot of effort on explaining this on the docs. And if you're more interested in learning about that, I'll be happy to connecting you with one of our platform engineers to go over the things. And I think there was maybe one more around. Says apparently this implies async IO is better for parallel HTTP. Okay, so there are a couple of links. Yeah, I think, yeah, I'm not sure I follow the other way. It seems like there was a conversation happening on the side, so might be in there. Do we have any other questions?
Okay.
All right.
Well, if that's all, then we'll end that for tonight. Thank you again, Dr. Clementi, for your talk. That was really interesting. I know for myself, I'll definitely be checking out these libraries in the future. For the other participants, if you haven't already, please fill out our survey. There's a link in the meetup page. That way we know what kind of talks you'd be interested in. And yeah, our next meetup is the notice is going to go out in a couple of days. So keep an eye out for that. And if anyone else would like to be a speaker, please email me and we'll set something up. So that's all for tonight. Thank you.
Awesome.
Good night.
All right. Thank you all.